This video is an introductory video looking at the early stages of quantitative statistical analysis, and we're going to focus on the base decisions. Now, the base decisions are the initial thought processes that you should make during your protocol design as you establish your methods and when you're first presented with a data set if you're collecting this from somebody else. What we're going to do is start off by looking at some of the key statistical terms, and then we'll look at how we organise our options for more advanced analysis based on the type of data that we have. As a starting point then, there are three very important terms, and I'd like you to pause the video and then just jot down a single sentence definition of what each of these terms mean to ensure that you have an understanding of these concepts. Okay, hopefully you've got those definitions down now. I'd like to just now present some of my preferred definitions for each of the terms. Data distribution, often we think about, is this normal or is this not normal? But a more complete definition will consider the fact that actually we're looking at what is the full range and frequency of data within a data set. So we can use this as an opportunity to quality check our data and ensure that the range of numbers that we're getting is within the range that we would expect, and that the frequency is similar at least to what we would expect, assuming that we have kept an open mind to the process. We don't want to introduce a researcher bias, but if we were looking at people's height and we were finding lots of numbers of people that were 5 meters tall, we would know that that's not possible and that there'd been some problem in our either note taking or in our data collection. So we can ensure that our data is of good quality. Central tendency are our three classic measures of mean, median and mode, and we use these to provide a representative measure of the type of data that we have collected or that we are analysing. If you're not familiar with these mean, median and mode terms, then I encourage you to pause the video and to quickly research what they mean and ensure you're very clear on the difference between them. The last term which I asked you to jot down was scales of measurement, and this is about how we categorise the types of number that we have. I think you'll sometimes see this presented with the acronym NOIR, as we have 4 categories for types of numbers. So I'm just going to walk through these individually so that you can ensure you have a good understanding. The first category is nominal, and this is just where we use numbers as labels. So they don't really need to be numbers at all. We could have group 1, group 2, group 3, and they could just as easily be group A, group B, group C. They have the order of the numbers has absolutely no meaning. So a classic example here is diabetes. If we have type 2 diabetes, that is in no way twice as bad as if we have type 1. Likewise, in a sports team, if we have players who have number 1 on their back and then another player who's number 4, that doesn't mean he is 4 times better than the player with number 1 on his back. They are simply just ways of labelling so that we can actually identify the different people in that team. The next category is ordinal. And ordinal is based on how we rank information. So we have an identity and we have a magnitude, but it doesn't have to be a consistent difference. So for example, if I had a group of people in a room and I asked them to stand in a line with the shortest person on the left and the tallest person on the right, then I could number them and say number 1 is the tallest, number 2 is the second tallest, 3 is the third tallest, and so on to the end of the line. But the difference in height between person number 1 and person number 2 is not necessarily the same as the difference in height as between 2 and 3, and 3 and 4, and so on. So we can rank people, but we can't distinguish that there is a consistent difference. If there is a consistent difference, then we have a scale. So now we have an identity, we have the tallest person, we have the magnitudes, but we'd also have a consistent difference. So obviously it's very unlikely that we would have this in an example of people standing in order of height. So we might look at the value of money in a bank account, for example, in which case, whereas if I have £20 in my account one week and £10 the next, then I do have half of what I had before. The final category is ratio, and this is very, very similar to interval. realistically, we're still looking at a scale, but the only difference now is that we have a point where we have an absolute zero. And this is a very important term here because this is actually really quite hard to find. And it makes such little difference to the way in which we deal with our numbers that in reality, most of the time what we do is we consider nominal, ordinal, and we group interval and ratio together. So you may just see this as a scale type group, or you may see nominal and ordinal listed as lower order numbers and interval and ratio as higher order numbers. So an example of a ratio type scale would be something like Kelvin temperature, where we have an absolute zero that you cannot go below. And this is different from Fahrenheit and Celsius scale, which are interval, because we can have negative temperatures when we use these scales. And this is one of the reasons why it's so difficult to try and look at the examples to present for interval and ratio. So for example, if I used money, then I could have a savings account where it's not possible to have an overdraft, in which case I have an absolute zero value, and I would have a ratio scale. But if I used a bank account where I can have an overdraft, then I have an interval scale. And often you'll find that there are lots of people that will argue about whether a particular type of number is on an interval scale or a ratio scale. I'm not going to do that in any of the videos which I create. I'm just going to group them together, because the truth is, what we can do with an interval scale, we can also do with a ratio scale. And so the arguments about which type of label we should put for these higher order numbers really doesn't achieve much in my opinion. So from this point on, I am simply going to group these together. Now the way in which I look at what to do in any given statistical analysis is going to be presented over a series of flowcharts. And the first thing I do is I decide what type of data that I have. So this comes to my scales of measurement. I'm going to group, as I say, I'll have nominal, ordinal and scale measurements, or lower and higher order. And this is what I'll do with my initial point. My first decision says, what type of data do I have? And then I'll present the subsequent decisions as these progressions along a flowchart. Now the base decisions always start with, is our data lower order or higher order? And so again, just pause the video as a point of revision, just make a note about what those four options are. The options for lower order are nominal and ordinal, and higher order are interval and ratio. Now, as a broad stroke, then we can say that if we look at the tools that are available to us, so if we have a statistical menu of every possible type of tool that we can use, then we could group these menu into a non-parametric section and a parametric section. And initially, at this stage, we haven't quite got enough information to know which tool we'll be using. Now we know if we have a nominal or an ordinal type number, then we will definitely be using non-parametric. However, if we have interval or ratio, all we know at this point is that we might be able to use a parametric analysis, but we can definitely use non-parametric on these if we choose. If we would like to progress this a little bit further, then what we need to do is start to look at the data distribution. Now we know that this is looking at the range and frequency of our data set, and we should be looking now to see, is this distribution what we would call normal, i.e. does it follow a normal distribution or a Gaussian distribution? If you're not familiar with that, then a further video will be created at the ways at which we can look at this. But the final base decision is saying, is our higher order data on a normal distribution? If it is not, then we revert to a non-parametric analysis. If it is, then we can apply either a non-parametric analysis or a parametric analysis. Now, presenting further videos which will talk through different types of analysis and how we'll select them, and what you'll find is that this portion of the decision tree that's presented here is always going to start with these base decisions, and so make sure you are familiar on these. This is a very short video, so I haven't actually got time to go into any further detail on these, and I would like to just remind you that these decision trees are my own design, And if you type statistical decision tree into your search engine, then you'll be presented with many other options. Please do look around those and see if there's any that you prefer, if any that make more sense or you're more comfortable using as part of the background reading, which you should be completing as part of general knowledge anyway.